Welcome back to the chapter Similar Triangles for Standard 10. So, we were doing some problems related to the Pythagoras theorem. So, in this problem it is given ABC is a triangle and the perpendicular OD, OE and OF are the perpendiculars, and now you have to prove these two results. Now, let us join OB, OC and AO, and let us name these sides as ABCD etc., so that it is easy for us to do the sum. So, now AF squared plus BD squared plus CE squared. So, we have to prove, you have to prove A squared plus BD squared is C squared plus CE squared is E squared is equal to OA squared is Z squared plus OB squared is X squared plus Y squared minus OD is R squared minus P squared minus Q squared. This is the first result that you have to prove. Okay. So, now let us take the triangle ODB. You can say x squared c squared is equal to x squared minus r squared. R squared plus c squared is equal to x squared. So, c squared is equal to x squared minus r squared. Similarly, we can write OD, we need a squared and e squared. So, here we will take this triangle AOF, we have we need A, C and E. A, C and E. So, C is already over. So, we need A. So, we will take AOF. Yes, AOF. Now, this is the hypotenuse. So, A squared is equal to Z squared minus Q squared. And similarly, we need E squared in this triangle COE. Y squared is equal to, we need E squared is equal to. So, E squared is equal to Y squared minus P squared. So, now adding these two, you will get A squared plus C squared plus E squared is equal to x squared plus y squared plus z squared minus r squared minus p squared minus q squared, and we got the result. So, you can again rewrite this as, this is AF squared plus BD squared plus CE squared is equal to OA squared plus OB squared plus OC squared minus OD squared minus OE squared minus OF squared. Now, we have to prove the second thing. Now, AF squared plus BD squared plus CE squared. So, that is again A squared plus C squared plus E squared is equal to, now AE will be F squared plus CD is D squared and BF is B squared. So, again we have A squared Z squared plus Q squared So now we will take triangle ODB and ODC. ODB and ODC. We can write in triangle ODB and ODC. We can write OB squared, that is x squared, is equal to R squared plus C squared, and then we can also write OC squared, that is y squared, is equal to R squared plus D squared. Now we have, let us subtract this. X squared minus y squared is equal to R squared plus C squared minus R squared minus D squared. So that is equal to C squared minus D squared. Now similarly, we can write now x squared minus y squared is C squared minus D squared. Similarly, we will write y squared minus z squared. Y squared minus z squared will be here. X minus y is C minus D. So y minus z will be E squared minus F squared. And similarly, y squared minus z squared. Now z squared minus x squared. So it will be a squared minus b squared. So here only one you have to do, similar, then you can write similarly. And then now again we will get x. So af squared. So here we will add, let us put this 1, 2 and 3. Adding 1, 2 and 3. So we will get x squared minus y squared plus y squared minus z squared plus z squared minus x squared is equal to c squared minus d squared plus e squared minus f squared plus a squared minus b squared. Here everything will get cancelled, so you get 0 is equal to. Now let us bring all the negative to one side. So d squared plus f squared plus b squared is equal to c squared plus e squared plus a squared. So that is what we have to prove. So you can write this as, now d squared is cd squared plus f is ae squared plus b is bf squared is equal to c is bd squared plus e is ce squared plus a squared is af squared. So here in this question it is given, it is a ABCD is a rectangle and point O is in the interior of the rectangle. It's any point inside the rectangle. Prove that OB squared plus OD squared is equal to OC squared plus OA squared. So now join OC, OD, OA and OB, and let us give the names as ABCD and EF, GH. Now construction is draw EF parallel to AB. So automatically it will be parallel to CD because ABCD is a rectangle. So AB is parallel to CD. Now EF, you are drawing through O. EF, a line EF passing through the point O parallel to AB. AB, therefore all the three lines are parallel. AB parallel to CD parallel to EF. Now here if you see, now these already this is a rectangle, so this is also parallel, that is EA is parallel to FB. Now EF is parallel to AB, therefore EF BA is parallel, and this angle is anyway 90 degrees, therefore this is a rectangle. So ABFE is a rectangle, that means AE is equal to FB and ED will be equal to AFC. Now we will start. We have to prove A squared plus B squared. It is A squared plus B squared is equal to C squared plus D squared. So now in triangle AOE, triangle AOE, C squared is equal to E squared plus G squared, and in triangle OFC, D squared is equal to F squared plus H squared. Now we will add this C squared plus D squared. This is 1 and 2. So 1 plus 2, C squared plus D squared is equal to now E squared plus G squared plus F squared plus H squared. Now here if you see the answer, C squared plus D squared is equal to A squared plus B squared. Now we have all the other terms except A and B. Now we have to convert these in terms of A and B. Now coming to this, we can say H squared plus E squared is equal to B squared, or H squared is equal to B squared minus E squared. So we will write H squared in triangle OED. H squared is equal to, this is 90 degrees. So H squared is equal to B squared minus E squared. Similarly, in this triangle H squared, then we will write in triangle OFB, we can write G squared is equal to A squared minus F squared. G squared and H squared we have done. Yeah. Now we will add these 3 and 4, adding or substituting to 1, 2, 3, 4, let this be 5. Substituting 3 and 4 in equation 5. So C squared plus D squared is equal to, now in the place of, now let E squared be like that. Now we will write G squared as A squared minus F squared. E squared plus G squared is written as A squared minus F squared, plus F squared is as it is, and H squared is B squared minus E squared. Now if you see, E squared and E squared will get cancelled, then F squared also will get cancelled, and you are left with A squared plus B squared. That's what you have to find. So we will rewrite this as A squared plus B squared will be A squared is OB squared plus B squared is OD squared. So OB squared plus OD squared is equal to OC squared plus OA squared.